Hi, this is the Physics Unit 1 video. We're starting on the back of page 9. It's not numbered. It's page 10. So this is a new look at average speed. So you have been told, especially in math class, that the only way to find the average speed of an object is to divide the total distance by the total time. Now that we're in physics class, there is another way to find average speed for a special type of motion. For uniformly accelerated motion. And this is only for uniform. The average speed over an interval is the average of the initial and final speeds of that interval. So let's take a look at how this works out. First, here is the formula that it's really talking about. So the average speed, that's this, over an interval is the average of the initial and final. So to find the average of these two, we add the initial to the final. So initial velocity plus final velocity. And the average is divided by 2 because there are 2 terms. Average velocity. So let's practice with these examples of uniform acceleration. So we have an initial speed, 30 miles per hour, and we have a final speed of 50 miles per hour. We are uniformly accelerating over this period of time. So our average speed, or V average, equals the initial 30 miles per hour plus the final 50 miles per hour divided by 2. The average of the initial and final speeds. So we have 30 plus 50, that's 80, divided by 2. The average velocity over this interval is 40 miles per hour. In the next one, we have an initial speed of 16 meters per second and a final speed of 22 meters per second. Average velocity equals initial velocity plus final velocity divided by 2. So we have 16 meters per second plus 22 meters per second divided by 2. And we have 19 meters per second as our average velocity over this interval. Another one, if we start at rest, which means an initial velocity of 0 and a final speed of 50 miles per hour, the average speed over this interval, initial velocity plus final velocity divided by 2, so we have 0 plus 50 miles per hour divided by 2, and the average velocity is 25 miles per hour. This is important. This only works. This only works for uniformly accelerated motion. In physics, we deal with this kind of motion often, so this is a good way for us to find the average speed. In Unit 2, we'll be able to do some problems easier if we can find the average speed this way. Now some notes. Physics students sometimes confuse acceleration and average speed. We're going to have a little bit more practice here. So let's take a look here. an initial speed of 30 miles per hour, final speed of 50 miles per hour, time interval of 10 seconds. So let's look at the acceleration here. Acceleration equals final velocity minus initial velocity over the time. So this is 50 miles per hour minus 30 miles per hour divided by 10 seconds. And the acceleration here is 20 divided by 10, 2 miles per hour per second. The average speed over this interval, V average, equals the initial velocity plus the final velocity divided by 2. So we have 30 miles per hour plus 50 miles per hour divided by 2. And our average speed is 40 miles per hour. The acceleration is how fast the speed is changing. The average speed is the average of the initial and final speeds. So these things are different. We have 12 meters per second initial, we have 18 meters per second final over a time period of 3 seconds. Acceleration equals, and we're going to use this same formula, Vf minus Vi over T. Try to keep it small but show our work. Final velocity, 18 meters per second, minus the initial velocity of 12 meters per second. Time interval is 3 seconds. So the acceleration equals, we have 6 divided by 3, 2 meters per second squared. The average velocity over the interval we have 12 meters per second plus 18 meters per second divided by 2, and that's 30 divided by 2, so 15 meters per second is your average velocity over the interval. Next row we have at rest. That's 0. Final speed of 30 feet per second over a time period of 6 seconds. So here's our acceleration formula, the change in speed over time. And we have 30 feet per second minus 0. Try again. Minus 0. Divided by 6 seconds. So we have 30 over 6, and that is 5 feet per second squared. The average velocity over the interval, 0 plus 30 feet per second, divide by 2, and that's 15 feet per second for the average velocity. Initial speed of 40 meters per second, the final speed at rest, which is 0, over time interval of 10 seconds. So acceleration is the change in velocity over time. Final velocity is 0 minus initial velocity 40 meters per second divided by 10 seconds. And our acceleration is going to be negative 4 meters per second squared. Average velocity initial is 40 plus 0 divided by 2, 20 meters per second. Last row, we have an initial speed of 30 meters per second, a final speed of 32 meters per second, and the interval is 10 seconds. Acceleration is the change in velocity over time. We have 32 meters per second minus 30 meters per second over 10 seconds. So we have 2 divided by 10, that's 2/10 meters per second squared. And the average velocity so the initial velocity is 30 meters per second plus 32 meters per second divided by 2. So we have 62 meters per second divided by 2, and our average velocity is 31 meters per second. In the next video, we're going to look at a speed time graph. This is a handout that I will need to give you in class, but it is available as a PDF on our site.